All right, I'm on take 2 here. I'm just going to erase some work and I'm going to start over here. We're on focus standard 4 and learning target B. I can create and model linear inequalities and 2 variables to solve problems. So our model is going to become our graph from our equation. So the first thing we're going to do when we graph this equation is think about graphing it with its key features. So I know that it's 0, negative 3 is the y-intercept because that's showing up right there. So I'm going to go 0 down, and that's 0, negative 3 right there. I know that my rate of change is change of y over change of x, and that is 1 over 2. And so that means I'm going to be going up 1 and over 2. That's my stair steps. Those are my driving directions. So I'm going to go up 1, over 2, make a dot. Up 1, over 2, make a dot. And continuing this pattern. And I would continue that, working that backwards. I'd go down 1 and back 2, down 1 and back 2, down 1, back 2, down 1, back 2, and down 1, back 2. Because it's an inequality, then I've got to be thinking about, is it a solid line or a dashed line? And since it does not have an equal to part of the inequality, it's just a greater than, and the line is dashed. It's not solid. I also know that I got to think about the shading. Y is greater than, so the shading is going to be all the true answers. And so because y is greater than, then the shading is going to be above the line. Okay, but then I'm just going to use a point, and I'm going to use the point 0, 4 as a point to check to see if this is a true statement. It should be a valid statement when I plug this in. 1/2 times 0, because I'm going to say x is 0, minus 3. Well, 1/2 times 0 is 0, minus 3 is negative 3. And we said that our y here is 4 because we're at 0, 4. That's always x comma y. So this is 4. And so bring this down. Is this a true statement? Is 4 greater than negative 3? The answer is yes. Okay. And by checking that, I checked that coordinate pair by plugging in the 0 into x and the 4 into y, and worked out that one side to get negative 3 and kept bringing down those 4's, and yes, that's a true statement. The other thing, though, that you can think about is when it says y is greater than, then you know the shading is going to be on the greater than side of a vertical line, on the vertical side here. So it's going to be above the line. Okay? Looking at the second one, we're currently in standard form, so we're going to turn it into slope-intercept form so that we can graph it. Drawing a line down, I'm going to subtract out 5x on both sides. I end up with negative 2y is greater than or equal to 2 minus 5x. And then what I'm going to do is I'm going to be dividing by negative 2, divide by negative 2, divide by negative 2. And when I do that, y, then this sign right here flips, because when I divide by a negative, my sign flips. It now becomes less than or equal to 2 divided by negative 1. 2 divided by negative 2 is negative 1. And negative 5 divided by negative 2 can be kept as a fraction because it's easiest for me to plot lines on fractions rather than decimals. But it becomes a positive 5 over 2x. You might also be writing 2.5x. All right, so key features. There's my y-intercept. 0, negative 1. 0, negative 1 is right there. Here's my rate of change. Change of y over change of x is 5 over 2. I'm going to go up 5. I'm going to go over 2 from my y-intercept. I'm going to go up 1, 2, 3, 4, 5, and over 1, 2, make a dot. Up 1, 2, 3, 4, 5, and over 1, 2, making a dot. And then I'm going to go backwards. Down 1, 2, 3, 4, 5, and back 2, make a dot. Down 1, 2, 3, 4, 5, and over 2, and making a dot. All right, I've got my points labeled out. It is an inequality, but it has an equal to part of the inequality, so the line is solid. Its y is less than, so the shading is going to be below the line on the side there. I'm now going to check a point. I'm going to check the point over 2, down 1. I'm going to call this 2, negative 1. And I'm going to check that point. So I'm going to see if my original equation is going to turn out to be a true statement for this coordinate pair. So I'm going to say 5. When I get to x, I'm calling x 2, right? That point right there. minus 2, parenthesis y is negative 1. So this looks like negative 2 when I got to the y times negative 1 is greater than or equal to 2. And so I'm going to solve this. 5 times 2 is 10. And then I've got the 2 times the 1 is going to give me a plus 2. And 2 plus 10 is 12, is greater than or equal to 2. This is a true statement, and therefore that's a true point. Okay? Go ahead and go on your own to complete that. Turn it in, and we will set you up for our retesting.